Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the data structure Trie. So basically we'll be implementing Trie and it's some of the functionalities, some of the functions of Trie. So suppose we are given, we have to store some strings, like we have to store. So we are first dealing with the function is insert. Suppose we have to insert the string A, B, C, D. Okay, so this is Trie. Suppose this is a data structure and we are inserting a string in it. So we have inserted ABCD. So if we'll check for ABCD, then search ABCD. So this will return true. Why this will return true? Because this string is present over here. So now we are searching for another string, that is ABCDE. So will this return true? No, this will return false. Why? Because no such string ABCD is present in the data structure. So now if we'll insert ABCDE, okay, so this will get inserted. So this will so now again if we'll search for ABCDE, so this will return true. Why? Because in this ABCDE is present. Now, so till now we have seen two functions, insert and search. Now there is one more function. If we'll search for function startsWith, and if we'll give some of the letters, starting letters of a string, then it will search for such a string which is starting with ABC. So is there any string present in this? Yes, there is. Basically there are two such strings, but it will check for at least one. If it receive at least one, then it will simply return true. So there is a string present which is starting with, which starts with. So this is starts with true. So this will return true because there is at least one string present which starts with ABC. Now if we'll check for starts with CD, so will this return true? No, this will not return true. Why? Because there are strings which are which contains CD, but doesn't starts with CD. So this will return false. Now let us take some other case. Like we have this case, to insert apple, and then so the apple will get inserted. The string apple will get inserted. Now it will search for apple. Is apple present? Yes, so this will return true. Now search for app. Is app present? See, apple is present, but a separate string app is not present. So this will return false. Now it will search for starts with app. So is there any string present which starts with app? Yes, it is present. So it will return true. Now inserting app. So this will insert app. Now search for app. See, previously when we searched for app, there was no such a string present. So it returned false. But this time we have firstly inserted apps, then we are searching for app. So it will return true. So like this, it will give such outputs. Now, see, if we'll talk about the searching mechanism behind any normal data structure, then what happens? See, if we have inserted apple, so apple will get inserted. Now, if we are searching for apple, so it will check character by character. Apple, is apple present? If it is completely present, then it will return true. And now if we'll search for app, so searching for app, it will search, but there is another string. Firstly, it will check character, it is ending after app and it is continuing after app. So this will return false. And if we'll check for starts with app, it will check for starts with app and it will return true. Suppose for this example, we have inserted A, B, C, D. It has checked for A, B, C, D. So it returned true because it was present. Now again it searched for A, B, C, D, E. So A, B, C, D, E was not present, so it returned false. Now again A, B, C, D, E is inserted. So it searched for A, B, C, D, E. So it was present. So it returned true. Now it searched for starts with A, B, C, D. A, B, C, sorry. So it searched for such a string which starts with A, B, C. So it found at least once. So it returned true. Now it checked for CD. So there was no string starting from CD. So it returned false. See, if we are searching in both these functions, we are basically searching. So if we are searching for any string, suppose that string is of length L and there are suppose present C, D, E, E, A, B, Z, Z, C, D, Z. Suppose there are n number of strings. So for searching mechanism, it will check how many times? It will check L into n times, which is quite large number. So what this trie does, trie basically works on tree data structure. It is somewhat similar to tree data structure. Now this trie improves the mechanism of searching. How? See, for normal data structure, for searching we have to make checks for L into n times. But in trie, if there are any strings, basically in trie, if we are searching for the string of length L, then we have to search for only L times. So we have to search only for L times. If we are searching for A, B, C, D, E, then we have to search for 5 times only. Means for A, for B, for C, for D, for E. So comparing to this numbering, this is quite small. So take some other example. And now we'll see basically how data is inserted in trie. So as I told you, it works on the mechanism of tree, somewhat similar to trees data structure. So how it is similar? Let's see over here. Firstly, we are talking about insert function. So basically how the values will get inserted. So firstly, what will be present? A root value will be present. A root is present. And if we have to insert this string car, so how? Basically, in each string, each letter is treated as a separate node, like in trees. So root, and it is having C, and then it is having A, and then it is having R. And after R, there is no letter present. So we also need to end it. So we will have some boolean that will mark it as ending point. Okay. So now other string is card. So while inserting, see, we'll first check from the root, is C present? So C is present. So for inserting card string, we'll not insert C. We'll move forward. We'll see if A is present. So A is also present. So we'll move further. Is R present? So we will move further. So is D present? So D is not present. After R, D is not present. So we will add D. And after D, there is no letter. So we will mark ending point. Now similarly for the cards, C is present, A is present, R is present, D is present, S is not present. So we will add S, will mark the ending point. For cot, C is present, O is not present. So we will add O. And after O, so we will add O, and after O, T. So T is not present, we will add T. And now after adding T, there is no letter present. So we will mark as ending point. Now C is present, we will check from the root. C is present, O is present, T is not present. Sorry, T is also present, S is not present. So we will add S and we will mark as ending point. After S, there is no letter. Now for adding try, C is present, T is not present. C. For adding try, we will check for T. From the root, T is not present. So we will add T. Now we will add R. So we'll add R. Now we'll add I. Now we will add E. So after adding E, there is no letter present. So we'll mark as ending. Now we'll insert tried. So TRIE is present. We'll add D in this. After D, there is no letter present. So we'll mark as ending point. Now we'll add tries. So TRIE is present. We'll add S. So after S, there is no letter present. So we'll mark as ending. Now TR is present. We'll add Y. After Y, there is no letter present. We'll mark as ending point. So this is how our try will look like. Okay. So now basically we'll see the searching mechanism behind this. How? See, if we are supposed to search a string or a word chord, then how is this will work? See, from root it will search for firstly for C. It will search for C. If C is present, then okay, now it will search for O. From C it will search for O. So O is present. Now from O it will search for R. So it will search for R, but there is no R present after O. So from here it will return false. So this is how it is working. So this we have seen for search operation. Search operation. Search operation basically it was finding for the chord, and from O there was no R present. Suppose if we take a word like now if we take a word like try, TRI. So if we are searching for try, then what it will do? It will start from root. So it will search for T. T is present. Now it will search for R. R is present. Now it will search for I. I is present. So it should return true because TRI is present. It should return true? No. It will return false. Why? Because search operation while finding for a word after ending at ending letter, after ending letter, it will search for the ending point also. But after TRI, there is no ending point. There is again a node present of E. So it should also have a ending point. For search operation, it needs a ending point. So I am writing here, search operation needs ending point for successful search. Now talking about another search operation which was starts with. So if we are searching for a word which starts with, suppose tr, tr. Then what it will do? Firstly, it will search for T. Okay, T is present. Now it will search for R. Okay, R is present. Now after R, this starts with function don't need any ending point. Not needed ending point. So as soon as we'll reach this R, then it won't search for anything. Now from here, if it has found T and R, then from here it will return true. Okay, so basically starts with and search operation are basically search operations only, but for searching we need the ending point at last, but in starts with we don't need ending point. Suppose we are searching for a word TIE. Suppose this is the function, it starts with TIE. So we'll search for T. T is present. Okay, now we'll search for I. So there is no I present. So it will return false. Okay, now we'll see the mechanism behind this insert function. How this insert function works in our try. So what we'll do, we'll create a class of C. If you can recall of generic tree, then in generic tree we were creating class of nodes, and what it was containing? It was containing an array list of childs. And similarly for binary tree we were creating the class of nodes, and it was having left and right. So it was having two children, so it was pointing to left and right. So for now, for tries, what we'll do, we'll create a class of try or node, whatever you want, and we will keep an array or vector of size 26. Suppose this is childs of size 26, and it will contain, why 26? Because we have 26 letters which will mark the indexing from 0 to 25. 0 will point to A or small a, or 1 will point to B or small b, and like this from A to Z, and a boolean which will mark as end, which will mark this ending point. So at every node we have 26. We can have any of this letter between A to Z. So we are creating an array of 26. So let us see the creation. So initially what we'll do, we'll mark this root point, and from here if we are inserting this for car, so we will create an array or vector, and it will have indexing from 0 to 25, and 0 will point to A, B, C, and this one is Z, and initially everything will be having null, pointing to node, it will be having null initially. And if we are supposed to insert the word car, so firstly we will point to this node of C, this node of C. So we will mark this C position, that is at index 2. We will create this node C. At index 2 we are creating node for this C. So we will add this C. Now for inserting car, again there will be, so so at here we were having 26 option, that is 0 to 25. It was pointing to A, B and C. So initially everything was null. Now we created at index 2 node for C. So for C, we have created. Now for again, we have 26 options, 0 to 25. Now we will again search for A. If A is not null, see, initially everything will be null. If A is not null, then we will insert A. Suppose A is present, it means it was not null. So here it is not null. And here A will become not null. And a node for A will be created. Now again for R, there will be 26 options. Suppose this is pointing to R. So this is not null and all other things are null. So it will attach R. Now at R, this is ending point. So, R will get its is end point. So this is end point is marked. Now we are supposed to insert this word card. So it will search for C. If C is null, then it will attach C. But here C is not null because we have already attached this C. So this is not null. If it is not null, it will simply move forward. Now it will search for A. For inserting A, from C it will search for A. A is also not null, so it will not add A node. Now it will search for R. Here also R is not null. R is not null, so it will not attach, it will not create node R. It will simply move forward. Now it will search for D. Is D present? So D is not present. So here what will happen at D index, the index of D, it will be marked not null. So now D will get attached. Now here again 26 options. So card, after D there is no option, so we will attach is end. Okay. Now for cards, again we will search for C, A, R, which are D. At D, S is marked as not null. Till here D was marked not null, so it was moving forward from A to R, from R to D. Now at D point it will check for S. So at S position it was marked not null. So it was initially it was null. Everything was null. Now for adding S, it was marked not null and S was created. Node S was created, and at S also it is ending point, so it will marked as ending point. For similarly for adding quote also, searching for C, then it is present. Then here also there are 26 options. So for searching for O, so A is not null, else everything is null. So searching for O, O will be null over here. So here O will be marked as not null and O will get attached to here. So at this point A is marked as not null and O is marked as not null. Okay. So this is how the elements will get inserted. Now we will implement all these functions which we have discussed: insert, search, and starts with in our code. So let's move to our code section. So we have to implement these 4 functions: try, insert, and search, and starts with. So in this try, we'll be initializing our data structure, and we'll be basically initializing the object. We have created the class try and we will be initializing the object in this function. So let's start. So firstly we'll be creating a class node. What this class will be having? This class will be having an array of node data type which represent the children and which will be of size 26. Why 26? Because there were 26 characters from A to Z, and a boolean to mark the ending point. So boolean is end. This will mark the ending node. So constructor of node, initially its end value will be false, and we'll be initializing this all the indexes of childs with null value. Initially these values will be null. So at every index there will be null PTR stored. So now our next work is to initialize our trie. For this, firstly we will create a node which will point to root. So this is our trie function. So this root will have new node. So till now basically what we have done, see, till now we have created a root. We have created a root, and that root is having a child's array of size 26. So it will point from 0 to 25, and this child's, at every index of this child's there is stored null PTR. So null PTR at every index. So till now we have achieved this thing. And also to this node, this boolean is and is also attached, and initially it is false. So this thing we have achieved. Now we are doing work in insert function. We'll be working on insert function. So one by one we'll be inserting the characters of the entered string. Whatever string is entered by the user, we will be inserting in the form of trie. So how we'll do this? Firstly, we'll have a root pointer pointing to current. So this is root. Now we'll start a loop from I equals to 0 till I less than the size of this word. Why? Because we'll be extracting each character of this word. So this will go till size of word, and we'll be extracting its character in ch. So this will be word of I. Ch will be having the each character from 0th index to size -1. So after that what we'll do, see, we have to insert this character. We have to create the node of this character. So firstly let us do, then we'll discuss what we are doing. So firstly we'll check if current of childs at index what? At index ch minus a equal to null PTR. It means we have not created any such node of such a character. We have not created the node of this character. So we will create the node. How we will create? This current of childs at index ch minus a. See, we'll be also be discussing on this index ch minus a. we'll get a new node over here. Okay, so now after creating the node, what we'll do, we'll point this current to next node. So that next node will be ch minus at index ch minus a. Okay, so at last we'll mark that true. Mark the current is end value as true. See, till now what we have done is we have created the root value. Now we have to insert the word. Suppose that word is cot. So indexes will be 0, 1, 2. So current is pointing to this root value. Now we'll enter into this for loop. Word dot size is 3. So firstly value of I is 0 and we'll extract the ch. We'll extract the word of I. So this is basically words. Sorry, no, this is word only. So word, this is word at index 0, it is stored C. So ch will have C. Now what happens? We have to see these indexes 0 to 25 are pointing to each letter. 0 is pointing to A, 1 is pointing to B, 25 is pointing to Z, 2 is pointing to C. So at the index of C, so how we'll get the index of C? See, if we'll do A minus A, then the code of A is something and the code of A is something. Then subtracting both the codes will result 0. Similarly, code of B, code of A will result in 1. Similarly, code of C minus code of A will give 2. So this means C has code 2, C has index 2, B has index 1, A has index 0. A is pointing to 0 index, B is pointing to 1 index, C is pointing to C index. That is why if we have to find the index, we are doing ch minus A. So at C, this time current is pointing to this and current is having a child's array and is and boolean variable. So at child's index of A, it will check whether it is null ptr. So this will result true. So what happens at this index at A the word is ch word is C. So at index of C, ch minus A means C minus A will give 2. So at 2 index the value stored was null ptr, but after getting this condition true, at this index there will get attached a node. So this will become not null. Now it is not null. So what will happen? This not null, how this not null will help for the next time? When we will be inserting some other word and this value is not null, and suppose that other word is cat, then we won't create this C node again. Why? Because when we'll come at this root position, this C index will give us not null value. And getting not null value means we will not be creating new node. So this will help like this. Now we will come at this position. We have created the node at 2th index. Now we will mark this current as new current. Now we will create a node pointing to C, and now current is pointing to current child's ch minus A. That means current is pointing to now C. Initially current was pointing to root. Now what happens? Again I will get incremented. This will become 1. So this will point to O. Now it is pointing to O. Now it will check current. Now it will create, firstly it will check. See, C is having 0 to 25 and is false over here. So initially is end value is false. So what happens here? current value will get current will check at ch minus a, that is o minus a. So o minus a will give index of o. So at index of o there is placed null ptr. So what will happen, it will check whether at o index null ptr is there. So it will result true. So what will happen, at this index a node will get attached at index of o, and what node, of o. Okay, and now current is pointing to this. So here o is at cth position, where at cth node the o index has become not null. Now o will check for t. So t index will become not null and o will have this t. Now I will, after adding t, now I will become 3. As soon as 3 I becomes 3, 3 is less than 3. So what will happen, will come out of this for loop and current dot is end becomes true. So right now current is pointing to t. So current of is end. See, this will become true. From here to here, C has is end value as false. It also has is end value as false. But at T, is end value is become true. It means this is the end. Okay, so this is marking as end. So this is how we are inserting. Now we will see the function of search. So our very first step is, we will be having the current pointing to root. Now we will iterate in our word. See, if you will see this function, so this is boolean search. See, this is boolean search function. It means it will return true if the string word is in the trie, and it will return false if it is not present. But here we have written data type string. Why? Because here when we are calling the function search, then we have to print the answer. So cout will print, if it has returned true, cout will print 1, and if it will return false, cout will print 0. So basically we have to print true and false. That is why we have changed the data type of this function as string. So it will print true instead of printing 0 and 1. So now we'll extract each character. And now we will check the indexes. So if current at child's index ch minus a is not equals to null ptr, then we have to return false. So let me erase this thing. So it will return false. And then current is pointing to child's of index ch minus a. So now after doing this, we will be returning value stored at current is end. If it is true, then it will return the string true. If this value is false, then it will return the string as false. So let us discuss this thing. So what will happen in this search function? See, we have discussed a thing in search function that we need a ending point, and in starts with function we didn't need an ending point. So what this ending point means, we'll discuss in this function. So basically we are searching for, suppose we are searching for word caught, then how this will work? This is pointing to current. Now it will extract the character ch. If this c, if at this root value, if cth index is having not null, if cth index is having not null, it means such a node is present. Not null suggests that such a node is already present. So it means we are going correctly. Suppose if it receives at cth index a null value, if at cth index we will receive a null value, it means we are not going in right direction. It means such a word having c character does not exist. So we will return false from here only. We won't check other statements. We won't execute other statements. We will return false from here only. If it receives not null value, since c is present over here, it will receive not null value. So what will happen? Now current will be pointing to c. Initially it was pointing to root. Now current is pointing to c. Now what happens? Again I value get incremented. I will become 1. Then again it will check for ch minus o, that is at oth index. It will check if at oth index there is not null value, then it means we are going in right direction. But if it is at oth index, if it is a null value, it means after c there is no o present. So if there is no o present after c, it means such a word does not exist in our try. So we'll return false from here. Otherwise we'll point our current to o now. Okay. Now again I will get incremented. I will become 2. Now what happens? When I will become true, it will get t. Now it will search at tth index. Tth index has, suppose this is not tth. This has been, suppose this has been b. Suppose this has been b. So it means at bth index there has been not null value. So it will check for t. So there is no t present. So what will happen now? Again I will get incremented. It will become 3. Now will come out of this for loop. Then it will check if current dot is end. So current is pointing to right now at b. Now current is pointing to b. So what will happen? It will check if this is end equals to true, then it will return true. See, again I am saying, I am repeating this thing. The size has become 3. Initially it was 2. The size has become 3, and it will check. It will check if current, see, if current dot child is ch minus, ch was t, ch was t, t minus a. So it will check at index t. So at index t there will be a null value. So it will check the condition at index t. If this is null, so it will return false from here only. So it will return false from here only. It won't check here at bth position. It will return false from here only. Why? Why? Because at tth position we have received null value. So this is what I was trying to say. One more thing we'll discuss over here. Suppose this word has been cots. Then at s index there had been not null value. So if we are searching for COT, then what will happen? We were the index, the I value was, suppose 1. So we were searching at 1th index, and current was pointing to C. Then it will check for O. Then will come at O. Then it will become 2. We are searching for T. So at this t there will be a not null value. Since node is created, so this is having at tth index there is not null value. So what will happen? Current will point to now t. Now at t, size will become 3. Sorry, I will become 3 and will come out of this for loop. Now what will happen? We haven't get trapped in this false condition. So it means we have received our searched word. It means we have successfully found our searched word that was caught. But no, how will implement this thing? See, we will also check this is end value. See, is end value is true at the end only. Everywhere else it is false. This is still false. So what will happen? See, we have word caught and we are searching for word caught. The word starting with caught is present, but the word caught is not present. How? Because is end value is false over here. So this thing will manage in this return statement. How? This will return true. It means this will return the value present at is end. So this will return the value present at is end. So what will happen? If this is end is false, if this is end is false, then it will return false. Why? Because we have some other letter also in our word. We have caught, but we extending caught, we have some other letters also. So it is pointing to false. So this will return false. And if it has been only this word caught, then is end value had been true, then it had returned true. Okay. So it means in search function we must have our is end value. We must update. So now we will discuss another function, that is starts with. I hope you have understood this trident. Now we'll discuss the function starts with. Starts with function is basically similar to search function. We'll do the same things, only a single line will be different. We'll discuss that. So this will point to, so this was current, this was current which was having the root, and we were iterating in our word. So this time word is prefix. So this will be prefix dot size I plus plus, and then we'll extract each character. At index I. Now we'll check if fixed current value at childs of index ch minus a equals to null ptr. It means such a node of character is present. So we will return false. See, this thing we have discussed, why we are returning the string, because the boolean value of true was would print 1 and the boolean value of false will print 0. So now here we'll update our current. Okay, so at last what will return? We don't need this is end function. If we haven't get trapped in this condition, it means we have found such word. So we will return true. See, this is the only difference in search and starts with function. We were returning current dot is end, and here we are returning true. So how this will work? C. So this was caught. Suppose we are searching for a word that starts with CO. So this is prefix. And here at Cth index it is not null. And here at Oth index it is not null. And here at Tth index it is not null. And here is and value is true, else everywhere is and value is false. So what will happen? We'll enter into this for loop. Ch is pointing to C, I0. Now at Cth position we'll check if this is null. So this is not null. It means C is present. So this won't get trapped in this condition and it won't return false. So now current will point to now this. Now again I will get updated. So this will become 1. Now Ch is pointing to O. Ch is pointing to O. Now we'll check at this Oth index. Current is pointing to C. Now at this Oth index, we'll check if this O is null. So this O is not null. So we'll not get trapped in this if condition. We'll update our current. So it means we have received our O also. Now current is pointing to O. Now again we'll come and update our I. Now I become 2 and here size of prefix was 2. So 2 less than 2 is false. So we'll come out of this for loop and now we'll return true. See, now this time we are not checking for the is end value. Whatever the value of is end, we are not checking for it. We are simply returning true if our string is completed, our word is completed for which we were searching. It means we have searched our word successfully. So I hope you have understood the dry run and the code. So now let's run our code. Okay, so there is some mistake, semicolon at the end of member declaration at line number 19. So okay, so class is, we'll put this semicolon. So there is some compilation error. Try node B is private within this context. So it'll make them public because these variables are private. So we are making them public. Current at line number 49. So here will be semicolon. Sorry, here. Terminating character if current. Okay. So 48. There will be single quote. Could not convert current from boolean to std. Okay, so here we will return the string. Line number 52. Okay, so actually we have marked this current is end as boolean. So this will be okay. So try is, so here also we'll make this variable as public. Okay, so it is accepted. Now let us submit it. Okay, so it is submitted successfully. It means all the test cases are passed. So I hope you have understood the question and its implementation of try with along with the dry run. So thank you for watching. We'll be meeting in another video with another concept.